In this final tutorial video, we're going to attempt to make Tyflow particles follow a precise path. So first we'll start with bringing our basic Tyflow into the viewport and also the Ty icon, the base which it's going to follow. So just for the purposes of this exercise, which will become very clear in a second, we'll just move this up. And we'll also specify a path that we want the Tyflow particles to follow. So for this instance, let's use a helix and maybe give it a couple of turns. So it has a little bit of a play in the form, and the particles are following an interesting path. So we're going to go to the Tyflow editor and just set a few basic operators at first, which will enable the birthing of the particles to take place and give them a speed along a specified surface. So we'll just quickly use the birth, and we want, let's say, 45 particles with 1.5 per frame. Then give them a particular position on a surface. So we're going to use the position icon, and just like the previous videos, we'll pick and select the Ty icon over here, and then give the particles a little bit of speed. And we're going to give them the speed along the icon arrow, just like before. So the idea is the particles are going to be birthed inside this Ty icon, then follow the arrow down and then take the path of the helix. So after we do determine the speed, what we can do is add some shape to it. So we're going to look up shape from the operators, place it under speed. Obviously we want a 3D shape. The high resolution torus, so they basically look like donuts or rings. If they follow a path on the helix, it should look pretty interesting. So we'll just leave it at that. Let's increase the size of the particles so they're visible. Increase them 3.5 times their original size. And we need to apply a physics operand for the particles to behave the way we want them to. So we'll give it a physics shape. And so right now you can see from this list that the system has to birth the particles, have them in a specific position inside this Ty icon with a certain speed. They're going to have a certain geometry, and what we need to do is specify the path that it is going to follow, which is the helix in this case. So from the operator menu, we're going to find and use the path follow operator. So over here, just drag it and place it here. And in order to connect these two lists of operators so they can function together and provide the output that we desire, we're going to have to use an operator called sendout. So the system understands that these two need to connect. So the sendout operator should be somewhere on the list towards the end. There it is. And you just place it under physics shape and just drag from this circle over here and connect it here by releasing the cursor. So now let's just quickly check what's happening. So this is not achieved what we were trying to, but there's a couple of more instructions that we are gonna have to follow in order to achieve what we desire. One thing I can notice is the particles are too fast, so they're just falling from the surface to the base of the helix. What we can do is we can slow down the speed at which the particles are moving, for which we can use a slow operator and just place it over path follow, and we can play with the velocity of the slow operator. In this instance, for X, I'll just leave it at 95% and see what it's doing. So as you can see, now the movement of the particles, because they have slowed down, is a lot smoother. Now what we're going to try to do is specify the path that it has to follow. So you go to the path follow operator, pick the helix, and you can double check by seeing here which shape it has picked for following the path. And now you can see that the particles are still not following the helix, and this is where it gets a bit more interesting. So if you look in these detailed parameter options inside path follow, you will find that every single component, such as follow, has a couple other more subcategories like velocity, the variation percentage, fall off, and acceleration. So does the attraction of the particles, their axial influence, and also their spin. So one way to test and let the particles follow the path of the helix is have a bit of a play with the parameters. So for spin, I don't want any spin to occur at all. Let me just put it at 0 right away. And for velocity, maybe we can try different numbers. So let's just start with 5 and see what it does. And for the following velocity, let's put it something like 5 as well. We can change these and see what kind of effect it's creating. So now I'll just quickly increase the size of the particles so we can understand what it's actually doing. So no, it's not following a particular path. Let's just try playing with the velocity with the different numbers. You can see they're now going down, but they're not following the path of the helix. So you can change them a little more. So I've had a bit of a play with all these parameters over here. So the acceleration percentage and the velocity, the attraction velocity, and you can see that my geometry is sort of following the path of the helix. However, you can change the parameters more and make the transition of these particles more smooth through the helix.